first day, right? So you have come here because there is class, right? So you want to complete your O-levels in 1 year. So completing O-levels in 1 year is not difficult and it's not easy, right? So I'm doing my part and you have to do your, right? So whenever I teach you something, you need to revise it and come back to the class, right? Because there are now first few lessons are not difficult, but when we go on, there are lessons that we need to really revise and come to the class. It's all connected, right? So that attitude should be there because for you to complete O-level in 1 year, you need to do papers in 1 year. So it's not easy, right? It's not easy. You need to do papers and also you need to cover the right? So we do 2 day classes, right? We have for chemistry, we have 2 days. For biology, for every subject, we have 2 days. And sometimes there may be an assistant doing the lesson, but most of the time I will be doing my lessons because I take initially I need to teach all, and then there are some easy topics which we can cover with our assistant. Right. And also we will be doing papers. You need to also keep your tunes in a file or something. Did you get a file today? No. Right. So keep your tunes in order. Put number 1. So you can easily, you have an order. And you won't have photocopy the tunes. Some students, they load all the tunes, and at the end they are coming to me and asking for the tunes. Now the point is, if I give you the tune, all these tunes are spaced right down certain things. So no point of me giving you the tune again. Then you photocopy it from someone else. So therefore, keep all the tunes in order, because I don't like when I go to university or school, I always need my notes, right? I always need my notes, not someone else. So therefore, you need to keep your notes in order, and also attendance is really important, guys. Don't be fun like any day, right? Try to attend every day, because sometimes there's a thing, right? So when you listen to my lesson, you will understand. But when you I have a thing like that also, from certain professors, when I go to the lecture, I understand. But when I don't go to the lecture and try to refer the notes, I don't get it properly. So that's like a big piece sometimes. So therefore, you need to come to the class every day. And also, I need to tell you something. This is a big serious thing. Okay, discipline is really important, right? So I always love my students, but there's certain discipline you need to have always in the class, right? And also outside the class, because you will be other people as well when you go to Sumanatisi, don't waste time there. Okay, so always don't get into trouble, maintain discipline. So if you now previous batch was really good, like the discipline was good, and I always told, I also told them earlier before anything happens, right? So maintaining discipline is really important, because we are very friendly with you, but we have to maintain certain discipline, right? If not, we have to take some action. So therefore, do not use your mobile phone in the class. We have a very strict policy on mobile phones, especially in our O-level 1 year program, because we want to focus more on the lessons, right? Because getting addicted to the mobile phone is real badly, right? It will distract you, right? Anyway, so those who have joined online should know a few things. I'm using 2 accounts, and I will send you. So if you have any question, you can always send your questions to my second account, just the Shehan 2, so that I can see your message from my laptop, because I'm using my iPad to write the notes and everything. Right. So today we will start our lesson. Let's go to the lesson, no? Right. So okay, before that, right? How many of you all are doing? So basically, are doing biology, I mean chemistry, biology, physics. Now, how many of you are not doing biology? Some are not doing biology. How many of you are not doing physics? Everyone is doing physics. Mathematics. How many of you are doing mathematics? That's a good thing. Okay, maths. You need maths always. Everything. Right? Good. Great. Other than that, there are other subjects as well. And also, how many people are doing Edexcel? Okay, we have like half kind of thing. How many people are doing Cambridge just to see? Okay, right. Now, Edexcel Cambridge syllabus is not really different, right? Knowledge. No. Because I'm speaking from the iPad, it's not on. Right. So chemistry, Edexcel, I don't know about that subject. Chemistry and Edexcel. Chemistry, Edexcel, Cambridge and Edexcel syllabus, they are not different. But when it comes to questions, slightly different. For an example, in Edexcel, there are questions. There's a question like one question sometimes where you get 6 marks. 6 marks, okay. But in Cambridge, you don't have like questions with that high marks. Like you have questions with 3 marks, maximum 3 marks, 2 marks like that. Okay. And for Edexcel, there are 2 papers. Few MCQs are there, but for Cambridge, there's an MCQ paper, full MCQs, and then they have Cambridge have paper 2 is structured paper, and you can select certain questions and do. And Cambridge students have paper 4, which is mainly focused on practicals, graphs like that. For Edexcel, there are 2 papers which cover the whole syllabus, and it includes MCQ, structured questions, and practical questions, everything. Right? So basically, when it comes to paper discussions, we have to discuss it. If separately, after second term, we will separate your to Cambridge and Edexcel because we want to do questions separately. Right. So those are the important things that I need to tell you. With time, I will explain other stuff as well. Right. So let's go to today's lesson. We're going to learn states of matter. Right. How many? Yeah. Others shall have to, right? How many states of matter are there? 3. Yeah, 3. You have learned, right? 3 states of matter are there, but actually there are 5. But we learned 3 because it's 3 is important. 3 is enough for us, but there are more than that. If you are interested, you can research on that. But we will learn these 3: solids, liquid, and gas. Right? We have seen solids, liquid, and gas. Right? And this is a solid. Right? You know what this is? I will teach you later. This is called pipette filler. Some of you know this. Some of you all have our foundation classes. I can see some faces from that class, and also some of you are there in my own class as well. So this is a solid, right? We will come to the details later. And this is also this is actually a metal, right? What this metal is? This is magnesium, right? So it comes as a ribbon like this. We will do some experiments with these metals, and this is another solid that is also a metal. I hope our online students also can see. Right, this is a metal. So I want to show you copper. This copper has a slightly different color. All these metals have this silvery color, right? But this copper has like slightly different color, brown color. And we will learn about copper, magnesium, all that. And I have some solids here, right? Sometimes solid comes as powder as well, right? So this is a nice solid. That is not the color of the solid. Right. You can see it's a blue color solid. Right. So this is called copper sulfate. I have brought these all these metals and this copper sulfate because copper sulfate is important chemical in our syllabus. So it has this blue color in solid state. Right. So that's what solids are. And then we have some liquid. You know what this liquid is? This looks like water, but this is some acid. So I'm going to drink some acid. It's water, not acid, right? Anyway, when you go to lab, never drink anything that is colorless because it can be acid, it can be water, so it can be some other substance. So therefore, don't straight away drink anything from the lab. Yeah, this is water. I just wrote it from downstairs. So I want to show you something about solid and liquid, right? Now solid has a fixed volume, right? It has a fixed volume. This is also solid. It has a fixed volume. And here, solid has fixed volume. And liquid, what do you think? I don't think I can transfer the whole thing each day, but you can transfer. It has fixed volume, right? If I transfer everything, it's possible, but I want to drink some. I can't drink from this one. This is actually called conical flask. We will come to these apparatus later. So it has a fixed volume. So liquid has a fixed volume, solid has a fixed volume. And how about the shape of a liquid? The shape of the solid didn't change when I put it to this container. The shape of the solid didn't change, right? But shape of the liquid is fixed. Previously, it has the shape of this glass. Now what is it? It has the shape of the glass, right? So it doesn't have a fixed shape, but it has a fixed volume. It has, but it doesn't have a fixed shape. It takes the shape of the container. Now, then we have gases. Where do we have gas? We have gas in atmosphere. How many gases do you know? Like in atmosphere? Like anyone know any gas? Hydrogen. Okay, nitrogen. Oxygen. Yeah, gas. Some gases are there in atmosphere. Some are not. Carbon dioxide. Yeah. Carbon monoxide. You know, carbon monoxide is a dangerous gas. Poisonous gas. You can kill someone with carbon monoxide. But don't try to kill anyone. We have to know about poisonous gases because when we handle these poisonous gases, we have to take some precautions always. Right now, the gas. If I answer everything. Now there's some gas here in this glass, right? So the gas takes up the whole volume of the container. So volume of the gas is the volume of the container. Right? So if I ask what is the volume of gas in this glass, you will calculate the volume of this glass. Right? Because the whole glass is filled with gas. This air. Right? So the volume of the gas is the volume of the container. That means the gas doesn't have fixed volume. Like liquid has fixed volume, gas doesn't have fixed volume. And gas doesn't have fixed shape. Doesn't have fixed shape. No, fix it, right? So let's go to the tune. Right, we have three states of matter: solid, liquid, gas. Right. This is how you draw it in diagrams. So we have to know how to draw it in diagram. So when we draw solid, you can see we have drawn all the particles. So for an example, right. So next page is empty, right? Can you go to next page? Some of you don't have the tube, right? Yes. But until you get the tube, can you write down in a book or some empty papers if you have? We have one. I pass it. One tube available. Is it? Right, how many of you all had your breakfast? So only some of you all had. Right. Okay, we will give a small break also during the class to have breakfast. Don't go home and come, right? Some of you all might live near Platinum, but don't go home. Just stay here and eat something, and come to the class. You have Sumanati, they have great food. You can try today and you won't eat next day. Right. Anyway, they have some good food. Don't tell them that I don't. Right. Anyway, right. If they ask to draw a diagram of a solid, let's do that now. Right. So they will give a box like this and ask you to draw diagram of solid. Right. So when you draw solid, you need to draw like particles. We usually use circles. Right. Like this. And they should be close to each other. You have to draw them close to each other, touching each other. Right. So another layer we can draw. Like this. 2 layers, 3 layers you can draw. Not like 1 layer, at least 2 or 3 layers we can. Right. Similarly, we will have to draw liquids. Right, you can see in solid the particles are nicely arranged, like they have a particular pattern, right? You can see they are touching each other. There are attractions between particles, like we can't see them here, right? So there are attractions. The particles are attracted. Well, like this, you know, it's like putting cement in between bricks, right? So the particles are fixed onto each other. And they can't move them, right? Because the particles are stick to each other, they can't move, right? But they can vibrate. They are only vibrating. They can't move. But in liquid state, it's slightly different. The particles are slightly away from each other, so we can draw liquid. And you will see a random arrangement. Okay, there's no fixed arrangement. You see sometimes particles touching each other. But it's like very random. It's like during the class, our students are like in solid state. When I give the break, they become like liquid state. There are some people, some students are here running, doing all these things. But I can see you sometimes. Yes, CCTV, you can't do anything bad. Right. Okay. So that liquid state. So random. They are sometimes touching each other, but the arrangement is very random, and the particles you can see they are far apart from each other. They are not like close to each other. Not everyone is close to each other, right? But when it goes to gaseous state, platinum, we have this what we call sports day, right? So it's like gaseous state is like sports day. Students are all over the ground, not in one place, running, no restrictions, right? Sometimes colliding with each other. So we can draw like a gaseous state. Particles are all over the container, you can see, but far apart from each other. So, so when you are a science student, it's really important to have good imagination skills, right? Now you need to understand how a solid looks like, and the particles are close to each other. They have like strong attractions. When you're close to each other, you have like strong attractions, right? Right. So, but in liquid state, you can see the particles are being far away from each other, and the attractions are not strong. So they're like touching, but they're not all over the container. You can see, and in gaseous state, particles are very free, right? They don't have like strong attractions. There are like tiny attractions, but they are not having strong attractions, and they are far away from each other and like completely random distribution you can see for gas, right? So this is solid, liquid, gas diagram. So you can see if you go to the previous page, page number 2, the solid, liquid, gas. And then after that, there's another state which we don't have to know actually. I have just put it as an example. Plasma is one example, and there's Bose-Einstein state, which is like bit complex. Like if you are interested in physics, chemistry, you will learn these other physical states later. But for O levels, even for A level, we need solid, liquid, gas state only. Right. Now we will go to the next page. Right, let's underline important things. In solid, the particles are arranged in a regular pattern, forming a lattice. So, underline, arranged in a regular pattern, forming a lattice. Can I see how many students don't have? Can raise your hand. 1, 2, 3, 4, 5. States of matter. Okay, guys, until you get the tutor, just write down like underlining part you can do during the break. Right. So the particles are arranged in a regular pattern, and we have a name for that. We call it lattice. So let's highlight that. So lattice is what we use when the particles are arranged in regular pattern. So this is always for solid. We use this term lattice. Lattice. There are different types of lattices. We will be learning. So between the particles, there are strong forces. Underline that there are strong attractions, strong forces keeping the particles together. Therefore, the particles can't move, they can only vibrate. They can't move, they can only vibrate. Yeah. So, how about solids? Do they have a volume? What is your answer? Yes. Yes, they have one, obviously. Let's write down some examples of solid. Now, we can write a lot of examples for solid, right? Your pencil, all these, this remote, all that. These are all solids. But let's write down some, because we are learning chemistry here. Let's write down some names of these formulas of these chemicals, right? How about voting solids? What do you call that? Ice, right? So ice. Yeah. My screen shall stop. Right, so ice. Okay, this is. Don't look at these games. Sometimes when I'm stressed, I play these games. Don't judge me, yeah? Dumb ways. Okay, let's go to the date. Right, ice. Now we also need to know how to write down the formula of ice. In chemistry, we call it H2O. Water is H2O. But how do we write? particular, this is ice, we can put simple S like this. Subscript in brackets, we put S. That's the formula of ice. H2O bracket S. S means solid. How many of you are like experiments? How many of you like, crazy experiments, like explosive ones? Right? We can do some experiment. We can do some experiment next day, Monday, right? We'll do an experiment on Monday. So I will be bringing. How many of you know dry ice? Dry ice. Have you been to weddings like they pour champagne and there's some suddenly this white color smoke comes out? And have you been to this restaurant called Sizzles? Sizzles. They serve food with like a lot of smoke coming and every drink has smoke coming. They put dry ice. Dry ice is carbon dioxide in solid state. So when you pressurize carbon dioxide gas, it becomes solid. Right? So you can buy dry ice. There are places where you can buy dry ice. But when you now because on Monday I'll be doing the practical. So Sunday night around like 12 in the night I buy dry ice. Because dry ice you can't keep in the fridge for a long time. But if you buy on Sunday night, I can demonstrate the practical on Monday morning. Right? So we will see dry ice is carbon dioxide solid. So we can write down dry ice. So that is carbon dioxide is CO2. And again, because carbon dioxide is in solid state, we will put S. Formula of carbon dioxide is CO2, and we will put S. Right. Also today we saw another solid called copper. I showed you all, right? Copper. Remember, this is copper. So it's a metal, but it has different color to other metals. It has this brown color. So you can write down copper. So the formula symbol for copper is Cu. And because it's solid, we will put S. Right, let's look at some liquids, about liquids. So liquid particles are not arranged in a lattice. So they don't have a particular arrangement. There is no regular arrangement or pattern. And the attractive forces are weaker. Now we can't say there are no attractive forces. There will be attractive forces between particles even in solid, liquid, gas. But in solid state, the attractive forces are stronger. In liquid state, it's slightly weaker. In gaseous state, it's much more weaker. And the particles are slightly moving freely compared to solids. Right. Liquids, do they have volume? Yes. That's why in a Coca-Cola bottle, you have certain volume, like 1 liter bottle, 1.5 liters, 330 milliliters. So like that, you have volume for a liquid. Right. Examples on liquids we can write down water. Yes, H2O, water is H2O. But because it's liquid, what should be right? AQ or L? L. Yeah, AQ we write, when something is dissolved in water, we write AQ. Right. So water is liquid. I have written simple L, that's not E, yeah, that's how I write simple L. Water. And there are other liquids also, Right. We can write down the liquid. This is another liquid like bromine. Right, bromine is an element actually. It's there in the periodic table. We write it like this: Br2. And simple L. It's a brown color liquid. Brown color. Brown color liquid. Very dangerous. Very dangerous. You can't, like, it's very corrosive. You have to wear chemical resistant gloves when handling bromine, otherwise it can be really harmful. Can you raise your hand if you don't have it? There are more liquids I will show you. So many liquids are there. Hydrogen peroxide. Have you seen hydrogen peroxide? No. We will be doing an experiment with hydrogen peroxide. Hydrogen peroxide, we clean wounds with hydrogen peroxide, right? How many of you all have seen what you call isopropyl alcohol? No. Some of you all have seen, right? When you go to hospital, you get that smell, like particular smell in the hospital, right? That's because they use isopropyl alcohol to clean this floor to kill germs. So alcohol, that's why they included alcohol in sanitizers, because alcohol can kill bacteria, right? So there are so many other liquids we will be learning. We only few examples we have written here, right? So let's go to the next page. Right. Now this is important. In periodic table, you know about periodic table, right? In periodic table, there are two liquids only. At room temperature and pressure, there are two liquids as elements. One is bromine. So you can see bromine is a liquid but highly corrosive. Underline that. Now that's the symbol for corrosive. So if you see this symbol, do not try to even touch that. So that is the symbol for corrosive chemicals. And it's a brown color liquid because you don't have the color print out. Brown liquid. And it tends to become gas, like, immediately. You can see, like, this is like a small conical flask. And you can see the top part of the conical flask. This part, like, can you see? That's also brown because some bromine has become bromine gas. So it can happen because it has a very low boiling point. So it becomes like a gas and it stays as liquid, but some part becomes a gas. And this is the other one. Mercury, highly poisonous. Mercury is a liquid. This is a symbol for mercury, Hg. Right? Mercury is a metal, but all these metals are solid, right? But this is the only metal in periodic table that is a liquid at room temperature and pressure, and it's poisonous. Have you seen mercury? Right? You haven't seen mercury? Mercury is there in the thermometer, right? In thermometer we use mercury. Now that's why we say when you use thermometer, some students, like, there are experiments where you stir, right? Stir the solution like this. Okay. So there's a stir, a particular stir that you can use. Sometimes glass foot you can use. Glass foot you can use as stir. And we tell students not to use thermometer to stir, right? So some students think that we are making tea or something. They are stirring with the thermometer. Suddenly the thermometer breaks and mercury goes into the solution, and that's real dangerous. So you immediately call your supervisor or the assistant to remove that mercury. Don't touch it. Don't do anything. Just let them remove it. That's a way to remove it. So mercury is poisonous. You can it can kill anyone. So therefore, mercury is really dangerous, and it's also called a heavy metal. Now, have you seen, like, sometimes we eat a lot of fish, Like it's a good to it's amazing, but because of the situation, I know all these factories there is a method to discard all these chemicals, right? But some of these factories they shape they send all these chemicals into river or something, and then from river it goes into ocean. And what happens is all this mercury, mercury is a heavy metal, so it stays for a long time. So the fish stays in this mercury and it stays in fish, right? It doesn't get removed. That's why it's dangerous. And then we eat that fish and we take mercury, right? So that mercury actually can go from blood to brain. So it can be really dangerous. Therefore, it can kill. There are certain incidents where people were killed using mercury, right? Don't try not killing anyone using mercury. Okay, we are here to kill anyone. Learn chemistry and kill someone. That's really good. Okay, so mercury is dangerous. And I have a small story about bromine. Bromine is very corrosive. Therefore, we don't give students mercury or bromine because bromine is highly corrosive. What do you mean by corrosive? It burns your skin, right? It can be really dangerous. Now, even in university, we have to use this bromine for a certain practical. But they gave bromine by adding it to water. So it is diluted, strength is lower, right? And there was a teaching assistant. We have in the lab, we have these assistants, teaching assistant or demonstrator, right? So they were, diluting this bromine from this big bottle, right? It's a brown color bottle, and this still is not even wearing gloves. Okay? So we thought, that idea is, putting, handling these chemicals and all, right? And he was doing it, and at one point he accidentally poured some bromine onto his hand. So immediately it started burning his skin. It can also burn flesh and bones, so it's that dangerous, right? So he was immediately taken to hospital, and I don't know what happened after that, because I didn't feel thereafter until I complete my degree, right? So he did definitely die. So on Facebook, I saw he got a full scholarship to USA, and luckily he was recovered, and now he has completed his PhD also. So, but bromine can be really dangerous. Don't ever try open a bottle of bromine. If you see this symbol, don't always avoid this. So, what are the precautions we should take when we handle bromine? We should wear chemical resistant gloves, right? We should wear gloves, right? When it comes to gloves, there are certain gloves, not like these thin gloves, like there are like big gloves we can wear because they are highly corrosive. And also when handling mercury, you should wear gloves. If you have handled mercury, you should wear gloves. Do not eat it, right? You get killed. Right. Let's last part before we take the break. Gases. So in gaseous state, the particles are further away from each other. Underline that. Further away from each other. They are far apart. So that means the attractions are weak. Very weak attractions between particles. So gases, do they have volume? Yes, they have volume, but the volume of a gas is the volume of the container. So let's write down that. Yes, so volume of gas is the volume of the container. They don't have fixed volume, but the volume is the volume of the container. So for example, this one is completely filled, or it's half filled. It's actually completely filled, no? See, there's liquid and there's gas, right? So once I remove the liquid, So the whole thing becomes gas, right? So the volume of gas increases when I remove the liquid. So volume of the gas is the volume of the container. Now example of gas, we do like so many examples, right? So what are the examples? You told carbon dioxide, it's a gas. So but carbon dioxide, so when you write the formula, CO2, there are other gases, we know hydrogen gas. H2. We will learn how to write these formulas later, guys. Okay, just to get used to this formula, I'll be giving you. We put G because it's gas. See, in bracket subscript G. Right. So other gases like nitrogen. N2 gas. Nitrogen is like a highly abundant gas in air. Air is a mixture of gas. In air, we have nitrogen, argon, carbon dioxide, all these like trace gases. Carbon dioxide is also there. In air, like around like 78% we have nitrogen gas. But it's a useless gas. I'll teach you why it's useless. It is because it's not well reactive. It doesn't react with other substances. So nitrogen is a gas in air. Oxygen. Why is oxygen important? Because we need oxygen, right? We breathe oxygen, breathe air, but we actually need oxygen, right? There's a politician who asked, what he said was in Sinhalese, oxygen can't. Like it's like, why do we need oxygen? So that kind of politicians we have, guys. Okay. So right, O2, oxygen is O2. Again, we put brackets. You can name so many gases. So many gases are there. Carbon monoxide, poisonous gas, nitrogen dioxide, another poisonous gas, so many, sulfur dioxide, so many gases. We are not going to write down those things now because we will be with time using these formulas, names, and all in our lessons, right? Right. Here we'll be learning kinetic particle theory. Right. So this is what kinetic particle theory is about. Right. When you increase temperature, so that means you are giving heat, right? Let's say we are heating this liquid, so we provide. So when you increase temperature, you are providing heat. That heat energy transfers into these particles, and then these particles gain some energy. So we call this kinetic energy. That means, right? So when we heat, particles gain kinetic energy. That means they start moving really fast. Right? Don't keep your head down here. Yeah. 6. Then, so always remember, so kinetic particle theory is like this. When you increase temperature, particles gain always kinetic energy. So when you gain kinetic energy, what happens? You start moving really fast, right? So this is what kinetic particle theory is about. So let's write down a short note on this. So this is what we need to write down. So when we write down a short note, we don't have to write down like everything in words. So we can write like this: when temperature is increased, kinetic energy is increased. Can write Ke for kinetic energy. Increase. Right, so it's like this now. Imagine how the particles in solid state, how are they arranged very close to each other, right? So when we heat, what happened? So now the particles are slowly gaining energy, right? So then they will start to vibrate because in solid state they can only vibrate, but up to after a certain temperature they can break these subtractions and they start moving further apart from each other. That's how solid becomes a liquid, right? So always remember when the temperature is high, kinetic energy of particles are greater. So let's do a small question here. Small MCQ. At which temperature the particles of water will have greater kinetic energy? So you underline and keep, and then we can check the answer. At which temperature particles have greater kinetic energy? Kinetic energy. So kinetic energy gives you energy to move, no? Right? So when temperature, what is our short note? When temperature is greater, kinetic energy is high. So what is the correct answer? 100. Easy, no? So when temperature is high, particles have greater kinetic energy. Now we'll go to the next page where we apply this. Melting, right? What happens when you go to the fridge and open your freezer and then you take ice, right? And then when you keep it somewhere, let's say you put it to a glass, right? Empty glass, and what happens? It starts to melt and it becomes what? Liquid water. So solid becoming liquid is melting, right? Your chocolate is melting, macha. Eat it soon. Is it like that, right? So melting is when solid becoming liquid, right? So no one like to eat liquid chocolate, right? Some of you like to eat melted chocolate, no? I hate chocolate. I can give all my chocolates to you all, right? Yeah, okay. So we'll draw like this. So in solid state, quickly we'll draw like solid particles. They are like close to each other. And then liquid particles touching, but not in like fixed shape. And then we can put an arrow like this. That's solid becoming liquid. So that's melting. So can you see, like in terms of kinetic particles, then can you see when temperature is increased? So to melt, we have to increase temperature, no? So when temperature is increased, particles gain kinetic energy. So they move further apart from each other. So that is how we apply kinetic particle theory for melting, right? When temperature is increased, kinetic energy of particles increase, and then solid becomes liquid. So what is the opposite of liquid becoming solid? So you put this liquid water to the deep freezer and it becomes ice, right? So that is freezing, right? So opposite of melting is freezing. So let's put an arrow, backward arrow, freezing. Are you freezing right now? Is the temperature too low? Yeah. Feel free to take the remote and quickly change if you freeze. And remind, it's good to wear something like that. Because some of you can't tolerate, low temperature. So better to wear something like a sweater or something. Right. So freezing is when you decrease temperature, no? So when you decrease temperature, we start freezing. That's because kinetic energy of particles decrease, so they come more close to each other now. But I'm freezing, let's come close to each other. So particles are also like that, right? So they go from liquid state to solid state because they are losing their kinetic energy. They can't run around, right? So kinetic energy is decreasing. So that is freezing. Right, let's see how they ask questions. So what we need to summarize here is solid becoming liquid is melting, liquid becoming solid is freezing. That's opposite. And then when temperature is increased, kinetic energy of particles are increased, so the melting occur, and opposite for freezing. Right. And also remember, there's a fixed melting point. For a pure substance, there's a fixed melting point. You know the melting point of ice. Ice melting point is 0. So that means after 0, if you increase temperature further, it becomes liquid. But below 0, it stays as solid. Right? But after 0, it increases. When you increase temperature, it becomes liquid. And then let's underline that ice melt at 0 Celsius. So I've given some notes, but I'm explaining everything in my lesson. So I won't be reading all these notes during the class. Yeah, so the freezing point and the melting point are same actually. Right. Liquid like water start freezing at 0. Water, ice start melting after 0. So that's like a fixed point. Right. Let's go to the next page. Next page, we have boiling. Boiling. Right. So what is boiling? Liquid becoming gas. Right. We see in the morning water boiling because my mother or your mother is preparing tea or coffee for you. Right. So water boils at 100 Celsius. So after that, it will become steam. Right. So steam is what you call water gaseous state. So boiling is liquid becoming gas. So let's similarly draw small diagram here quickly. So we have liquid particles randomly arranged, touching each other. And then we have gaseous particles all over. And then we have this solid, not solid, liquid becoming gas. And we can put an arrow like this. So boiling is when liquid become gas. And again, we can see when temperature is increased, kinetic energy is increased. Kinetic energy of particles like this. So now they are further away from each other because they can move fast now. So that's when the boiling occurs. So now see, when you heat, right, particles gain more kinetic energy. And the attractive forces are broken. No, there are like strong attractions here, but they also break. When you provide heat energy, these attractions break, right? So you can see now the particles can freely move nicely like that. So the opposite of gas becoming liquid, condensing. Condensing. We call it condensing. That's when temperature is lower because then the kinetic energy is low and the gas becomes liquid. Sometimes we will see like very good Nuvareli, all these glasses. You can see the water is like water in air, like we call it moisture. All that is becoming liquid, and you can see the whole glass has like liquid water now because when it touches the glass, because the glass is cold, the vapor become liquid. So condensing is that condensing. So what's the opposite of boiling? Condensing, right? So that is when gas become liquid. Again, for boiling, there's a fixed boiling point. Boiling point water is 100 Celsius. We should know that. And boiling point usually you don't have to memorize, but water is something that we learn always, particularly. So water boils at 100 Celsius, and for different liquids, the boiling point is different. Okay, for different liquids, the boiling point is different. Right, ethanol is another liquid that we learn in the syllabus. We learn ethanol and water and ethanol. They have like a very close boiling points. Very close boiling point. Around like ethanol boils around at 74, 76. I think around 76. But water at 100. So boiling point of water is slightly higher than ethanol, but they have like close boiling points. Right. So let's underline condensation and boiling. Okay, at the same time. Now there's this fun part, next part. Right, before we go to that, we will do this one. Right, melting point of nickel is 1452 Celsius. Oh my God, very high. That's because nickel is a metal which is really strong and it melts at like really high temperature. Melting point of silver is 951 Celsius. Which of these metals have strongest attractions? So one with the higher melting point has strong attractions, right? So when the attractions are strong, we have to give a lot of energy to break them, right? So the particles are holding onto each other, right? They have strong attractions. When the attractions are strong, we have to put a lot of energy to break it, right? So that means we have to melt. You can see nickel by giving very like high amount of heat, 1452. So the one with higher melting point has the strong attractive forces. So we can write down answer is nickel. Because the melting point is high. Sometimes, you know, people will also do these things, okay? When there's a strong friendship, they're like, oh, we have to break this friendship somehow. We should gossip and, you know, tell this and that to them. And so you have to put a lot of effort, right? If the friendship is strong, you have to like, if you want to break it, it's really bad, don't do that, right? So you have to put a lot of effort. Like that, when the attractions between particles are strong, you have to put a lot of effort, a lot of energy to break it. So you give a lot of energy when you supply a lot of heat. So that is why nickel melts at very high melting point. You get it, right? So nickel has strong attractions compared to silver. Right now, there's another question. Boiling point of ethanol is 78 Celsius. State whether the attractive forces between ethanol molecules are stronger than water. Now, attractive forces in water, are they stronger than in ethanol? Yes, do you agree? Yeah. How do we know that? Because boiling point of water is greater than ethanol, no? Because we know boiling point of water is 100 Celsius. You can write down water boils at 100 Celsius. Therefore, attractive forces between particles of water are stronger. So if the melting point is high, if the boiling point is high, that means the attractions are strong. A lot of energy is required to break the attractions. I don't think everything is clear up to that. Right? All simple, right? So let's go to the next part. Right. Before we complete this, right? Okay, let's complete this one. Can you complete the green arrows? So what you need for, like for an example, what you need to write down is if the arrow is going from here to there, so we can see this is. Shall we write down? This is solid. This solid. This is liquid, and this is below. We have gas. For an example, what you need to write down is, if you want to write down about this arrow, green arrow going from left to right, that's melting. Yes. So can you complete the green arrows? From the screen, you can see the colors, but in the tube, it's not colored. And the purple arrows. Right. How many of you all have completed? Very good. Right. So there's the opposite of melting, that is freezing. Very good. Super. Right. And this liquid becoming gas is boiling. Condensing is the opposite. Right. Then we'll come to this part. This is something very rare. Some of you all have heard this. Right. How many of you all remember now? Some of you all in my foundation class. We have this foundation class, like before grade 9 class, we have this foundation class. If you like to join, you can actually join. If you have your brothers, sisters, you can tell them, like we teach them what you need for O-levels initially to give them a boost. Right. So how many of you know what is when a solid becoming gas? What do you call it? Solid directly become gas, no liquid. We call it sublimation, right? So I'm gonna show you a small video, and we're gonna do a small experiment next class. If you have, if possible, buy some gloves and bring. If you have these gloves, not chemical resistant gloves, normal gloves we wear, right? Like the rubber gloves. If you have, you can bring it because we are going to do an experiment. Right? I'm going to let you all try different things by using dry ice, right? Because it's really important to do that experiment. You will learn a lot of things about carbon dioxide. A few things you have even thought of, right? Anyway, I'm going to show you one video of this sublimation. Have you seen any experiment other than dry ice experiment? Have you seen any sublimation experiment? Right, so that's right. This is the experiment. Right. What we can do in this experiment is we can take some iodine, right? Iodine. You can see in that bottle we have iodine. So iodine is a solid at room temperature, and we're going to heat some iodine, and we see iodine straight away becoming gas. So that is called sublimation. From solid to it becomes gas straight away. No liquid state. So we need a burner, we need a wash glass, we need a filter, and we need solid. Initially, we can heat out beaker. When the beaker is hot enough, we take the beaker but use gloves to hold the beaker. And this is what I need to show you all. See, iodine. This is iodine, right? It looks like a metal, same color, gray color, right? It has this gray color. So in solid state, iodine is gray, right? And it's a solid at room temperature. Remember, these colors are important, okay? So iodine is gray color when it is in solid state. Now we will heat some iodine. What I'm going to do is I'm going to put this iodine into that hot beaker, because the beaker is hot. Particles gain more kinetic energy, and it's too much kinetic energy. So iodine straight away goes from solid to liquid gas, solid to gas straight away. So we call it sublimation. Remember the term sublimation. Right now, see what happens. That's important. Immediately it becomes purple vapor. Iodine in solid state gray color, but iodine gas, the color is purple. Yes. You can do that in the class. So after that, what I'm going to do is, I wanted to reverse it now. Now solid becoming gas. Solid becoming gas, one sublimation. So that means gas also can become sublimation. So we have to try and reverse it. So you can see what I'm trying to do there. I'm going to keep that we call it watch glass. So I'm going to close that beaker. Right? We have a beaker there like this. This is the beaker. So you have close this beaker so that the gas will not escape completely. And we're going to keep a watch glass. So that is made out of glass, and I'm going to put some ice. Then what happens? Glass becomes very cold. And then this gas hits the glass. Because the glass is cold, it will become solid. That should happen, right? So we will do that now. So I'm going to put some ice and take out the glass. So I'm going to put some ice so that the glass is becoming colder. And now the vapor hits the glass. And now the vapor loses kinetic energy. And it should become solid. So if you look at underneath this, crystals. So we will make it out using very nice you have to see. So this is opposite of sublimation. Sublimation is when solid directly become gas. So opposite of sublimation is what you call deposition. Deposition, right? Sublimation and deposition. Sublimation is when solid directly become gas. Is there a liquid state? Did you see any liquid state? No, we don't see any liquid state. It's only when solid directly become gas sublimation. So let's go to our table. Right, so solid becoming gas is this arrow. Sublimation. Sublimation. And opposite of sublimation is deposition. Sublimation, deposition. And that happens with carbon dioxide. So carbon dioxide solid will become carbon dioxide gas, and that is sublimation. We can also do opposite, but it's not very simple compared to iodine experiment, and that is deposition. Right. So let's go to this page. You can see Sublimation is when the solid becomes gas. So two examples we can demonstrate are given here. And we can write down the next topic, deposition. So that is when gas directly become solid. Gas directly becomes solid. Right, we can do a question now. Right, as science students, guys, we also need to think and do, right? We can't like memorize everything like a parrot and answer questions. We think and write answers always. So that's what you need in a science students. No? Otherwise, you can do a different subject. Right. So we'll do a small question. It's not a difficult question. Just think and give me the answer. We'll write the question first. Right, melting point of X. Use X for like unknown compounds. Melting point of X is minus 50 Celsius. Minus 50. There are like solids with very low melting point. And the boiling point is 20 Celsius. Melting point is always lower than the boiling point. Like water, the melting point is 0 Celsius, a boiling point is 100 Celsius. Here, the melting point is minus 50 Celsius, boiling point is 20 Celsius. So what is the physical state? Physical state of X. It's the physical state of X. Physical state means whether it's a gas, whether it's a liquid, or whether it's a solid of X at minus 5 Celsius. So you need to find out whether X is liquid, whether it's a solid, whether it's a gas at minus 5 Celsius. If you have found the answer, you can raise your hand. Sometimes we might get the wrong answer, don't worry, there's no one to laugh at you. Okay. Some of you have found the answer, some of you are still thinking. You always think and do, no? Sometimes students, they don't think and do, they look at right hand side or left hand side. What's the answer? What's the answer? But when you go to exam, your mother is not. Okay? So therefore you need to buy yourself everything. Right. Okay. Let's see the correct answer. How many of you think X is a solid at minus 5? Anyone? No one thinks. How many of you think X is a liquid? Okay, most of you think. How many of you think X is a gas at minus 5? Okay, right. Let's see whether your answer is correct. Now it's like this. No. Let's learn with mathematics now. When we are in grade 1, grade 2, not grade 1, grade 2. But when we are learning maths, we learn, okay, the 0. So after that, there's negative values and positive values to right hand side, negative to left hand side. No, so minus 50 is this, no? Right? Let's say plus 20, no? Plus 20 here. So after minus 50, anything lower than minus 50 should stay as a solid, no? Because after minus 50, it start melting, no? Once you increase the temperature after minus 50, when you increase, it should become solid, no? I mean liquid, no? Right? So now, at this stage, this should be liquid. But after 20, what happens? It becomes a gas, no? So that means at 30 and 50, it will be a gas. So where is minus 5? Minus 5 somewhere here. So it should be a liquid. So the answer is liquid. Should you understand now? Right? Because after minus 50, minus 5 is greater than minus 50. So after minus 50, it should melt. But it will become gas after 20 Celsius. So minus 5 is between this melting point and the boiling point. So this should be liquid. Is it clear now? Right? Okay. So next we go to the next page. We will learn about now diffusion. Right, diffusion. Diffusion is something very important. Okay. Now, when substance go from high concentration to low concentration. Right? Now, how many of you like perfume? How many of you like perfume? I like perfume. Right? I like different perfumes. Right? So you like to wear perfume. Right? So when you wear perfume, you spray here. You know, there are places, certain places you need to spray so that the other people will get the smell nice. And so that's a good vibe, you know. Wearing perfume, not to show off, like you know, it gives a good vibe to people that we meet, right? Right. Now, some perfume stays for a long time, right? Certain perfumes that stays for a long time, certain perfumes don't stay for a long time. So that's why there are perfume for night. There are perfume that we are in the morning, right? So there are different perfumes. Today's lesson is not about perfume. Now, when you wear perfume, the perfume is stuck into my clothing, right? So there's a lot of perfume here, right? But when I come to the glass, this perfume, right? So there's high concentration of perfume, lot of perfume, right? So this goes from my shirt or my clothing to the classroom, to the air, because in air there's no perfume. So it goes from high concentration to low concentration. It's a natural thing. Naturally, the particles will go from high concentration to low concentration until it is saturated. Right? So it goes from high concentration to low concentration. So that is what we call diffusion. Very simple, no? Diffusion. So diffusion is that. So you can see like if I can do a small quick example, right? We can do like this. You can, because there's a board here. You can take that solid now. We'll do like this. We'll add some water to this. Not a lot. And we got some solid. This is what we call spatula. This is not a spoon, okay? Spatula, and we add the solid, and we can leave it for some time. We add the solid, right? We can leave it for some time. Use what will you see after? What do you hope? Thanks. The solution becomes the water becoming blue color. That is what you call diffusion, right? So this solid goes from like solid is like highly concentrated there, but it will spread. It will spread, right? So I hope you understand high concentration and low concentration. I can give a small example. Now after class you go home and your mother will prepare lime juice because your mother loves you a lot. She will put lot of lime to small amount of water, and then you will say, "Mama, this is highly concentrated. I can't drink it." You can't drink it because there's a lot of lime in small amount of water. And then your mama will be like, okay, I'll please add a lower concentration. She doesn't do that. Put more water. Exactly. So that's when the concentration is low, right? So high concentration and low concentration is like that. Right. So particles move from high concentration to low concentration. That is what we call diffusion. Right. So diffusion, we will go to the tube now. Okay, we have around 10 minutes left. Right, diffusion. You can write a short note there. Particles moving from high concentration to low concentration. So now in O-level class, I had this crazy question. From O-level only, I started loving chemistry. I did my degree in chemistry, specialized in chemistry. I kind of, hated biology, but I love mathematics. But biology becomes important also when you learn chemistry. I had this crazy idea. I always wanted to become a chemist and do these crazy things like making nuclear bombs and stuff. And I didn't have plan on killing anyone, but I was really interested in nuclear chemistry and forensic science, all this DNA, all this stuff, okay? Because all these are related to chemistry. Now, anyway, I had this crazy idea. I was thinking, okay, particles are moving from high concentration to low concentration. Who is telling them to do that? Why can't they stay in one place, right? So that's the mystery in science. There is a reason why it happens. So I can explain that to you in A-level class because there's another phenomena behind this. So this is where we start thinking. I'm not giving you this complex thing, right? So this is what I thought. Okay, this happened. So why does it happen? Who is telling? Particles who go from high concentration to low concentration is a natural thing that happens. There are so many things that naturally occur. There is a reason behind that. I will teach you all if you come to my A-level class. There is a reason behind that. So all explain using mathematics, physics, and chemistry. So it's not complex. It's a very simple thing. Okay. Right. So anyway, so diffusion is that particles moving from high concentration to low concentration. That is diffusion. So you can see when you put some ink, we can try and do some experiments the next day of diffusion. We put some ink to water and you see the whole water solution becoming purple color, green color like that. But the color is not very dark. In the ink bottle, the color is very dark. But when you put it to water, the color becomes lighter. But because all the particles will spread throughout the solution. You can see the next diagram. See, initially you have this. This is called KMnO4, potassium manganate 7. You can write down the formula. This is KMnO4. It has this purple color. These colors are important. Because you can't see the color, you can see purple. You can write purple. This KMnO4 is purple. So we have added some KMnO4 to water. So after a while, you can see the whole solution is becoming purple color. That's because KMnO4 it starts to diffuse. And after diffusion, you can see the color is slightly lighter than initial color. Initial color is like really purple color, but after a while it will become slightly purple, not that dark. So that anyway, particles moving from high concentration to low concentration. This is another one. In this one, what they have done is they have taken nitrogen gas. Nitrogen gas is brown color. Initially, what they do is they do something like this, right? Initially, they keep this jar. Initially, we have a jar like that. Okay, and they keep something to close the jar like that, right? Then you put another jar upside down, and then you remove this part, pull out that part. What happens? So the nitrogen diffuses, right? Nitrogen diffuse. So you can see in the diagram, it's almost diffusing now. So you can see this part is light brown color because it's not completely diffused. And here high concentration, you can see high concentration, it goes from high to low concentration, that is again diffusion. So this, if you do it in the class, this can be really dangerous because nitrogen is a toxic gas. So I'm telling you about toxic gas so I can save you. If someone tries to kill you, you know, answer, oh, this is toxic, I should not touch this and all, right? And don't take it to the other side. Don't try to kill someone using nitrogen gas. Okay, right. Nitrogen gas is toxic. So how do we do this experiment in the lab? Right. In this class we can't do it because in the lab we have a particular part. We call that fume pool or fume cupboard. So it's like a small cupboard where we can put our hands in and then do the experiment, but the gas doesn't come out. There's an exhaust fan that takes out the gas and goes into the atmosphere. So it is not harmful. So when we handle toxic gases, we must do it always in the fume cupboard or fume pool. And also we should wear mask. So that's important. Right. So nitrogen gas example is given. Right. So we have a small question. Bromine is corrosive. What precautions you should take when carrying out this experiment? Wear chemical resistant gloves. Very good. Chemical system. And also what we can do is in a lab always we can wear lab coat, right? Lab coat we can wear. Like when we do like, you know, main experiments, I will always ask you to wear, not to wear shorts, always wear shoes and like trousers. We prefer trousers because then if some kind of chemical, but always, you know, these chemicals we bring, they are not very dangerous because we don't use in our O-level labs, we don't use like very corrosive chemicals. But if we go to a normal lab, we don't know, like, you know, let's say we are doing a lab session, but we are handling, we are using these diluted solution, not strong corrosive solution. But before our lab session, there may have been another lab session where they have used some dangerous chemicals, and some chemicals can be on the floor, we can't see it, right? So therefore, when we go to like main lab, we should always wear, you know, gloves when we use these corrosive chemicals, and lab coat whenever possible. Usually, we don't wear lab coat always, but in university we have to always use lab coat. You can see like my lab coat, if I show you, it's like you know, that I was at a home, right? Everywhere there are patches, because all these chemicals can be really corrosive. Right, nitrogen dioxide is poisonous. What precautions you should take when carrying out experiment? Because it's a gas, we should carry out the experiment in fume cupboard. fume cover. And wear mask. But actually, for a poisonous gas, normal mask is not enough. We have this particular mask. Have you seen, like if you play Call of Duty, you see this gas mask, right? So we have to wear those kind of masks. If it is a really poisonous gas, and if you are carrying out like high concentration of that, low concentration is fine. Fume is sufficient. Right. So these are the precautions we should take. Right. Okay. Next day we will learn more about diffusion. And right, remember what I always tell, at least 10 minutes you need to quickly revise and come to the next day class. Next day we will have one day chemistry, other days we have subject. Right, okay, you guys then.